Okay, class, today we are going to do 8.4 on the binomial theorem, and we are going to use the binomial theorem to calculate binomial coefficients, and then we're going to talk about the Pascal's triangle, how to get these binomial coefficients, and then use these binomial coefficients to expand out binomials. Okay, so first to do that, we need to talk about combination. So a combination is when you have a group of n objects and you want to select r of them at a time, and order is not important. So if you had, say, 5 coins and you want to make groups of 2 coins, how many different groups of 2 coins can we make from these 5 coins? That would be this example, 5 choose 2. So in the alternate notation, you have 2 notations here. This is 5 choose 2. We have 5 objects. We're going to choose groups of 2 of them. The order in which these things are selected, like the first coin I select or the second coin I select, doesn't matter. All that matters is that I have a group of 2. Okay, so when we expand this out, we have n factorial, which is the bigger number, 5 factorial, over r factorial, which is 2 factorial, n minus r. So then you subtract the numbers. 5 minus 2 is 3 factorial. You don't need the parentheses. You expand it out. 5 factorial is 5 times 4 times 3 times 2 times 1. 2 factorial is just 2 times 1. 3 factorial, 3, 2, 1. Cancel things off. 3, 2, 1. Cancel 3, 2, 1. 2 goes into 4 2 times. So you have 5 times 2, which is 10. So 5 choose 2 is 10, which means, for example, if you had 5 coins and you wanted to choose groups of 2. So I take these 5 coins, I want to put them in 2 groups of 2. How many ways can I do it? 10 different groups of 2. Okay, let's move on. So let's talk about Pascal's triangle. So for Pascal's triangle, we have row 0, row 1, row 2, row 3, row 4, and so on. Notice row 1, you have a 1 there. Row 2, you have a 2 there. Row 3, you have a 3 there. Row 4, you have a row 4 there, or down the other diagonal. That's one of the many patterns you can find in Pascal's triangle. The way we find the next row is the 2 above the number sum to be that number below it. So 1 and 1 make 2. 1 and 2 make 3. 1 and 2 make 3. Okay, 3 and 3 make 6. 3 and 1 make 4. So to find the next row, well, 1 goes on the outside. 1 and 4 is 5. 6 and 4 is 10. 6 and 4 is 10. 4 and 1 is 5 with the 1 on the outside. So the next row, the 5th row, is 1, 5, 10, 10, 5, 1. And notice down the center, it's symmetric. 1, 5, 10, 10, 5, 1. 1, 4, 6, which is on the line. 4, 1. It's symmetric on either side of the center. Okay, so here is find the third term of the 10th row. So the Pascal's triangle is recursive in a sense, where you have to know, if you want to get to the 6th row, you have to know the 5th row. So to get to the 10th row, we have to know the 9th. For that, we have to know the 8th, 7th, 6th. So we'd have to expand this out several rows to get to the 10th row to find just the third term. And the third term would be going from the left, 1, 2, 3, the third term in. Okay, like this is the third term of the 5th row. Okay, so instead we have this other notation using combinations where it's set up exactly the same, and using combinations you can get the exact Pascal's triangle. 0 choose 0 is 1, 1 choose 0 is 1, 1 choose 1 is 1, 2 choose 0 is 1, 2 choose 1 is 2, 3 choose 1 is 3, 4 choose 2 is 6. They're in the same positions. So you can write out Pascal's triangle by expanding it out and doing the 2 above it to get to the next. Or you can use the binomial coefficient way, which is by using choosing. So the first row starts off with 1 choose 0 and then 1 choose 1. The second row, 2 choose 0, 2 choose 1, 2 choose 2. The 4th row, 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4, and so on. So the 10th row would look like 10 choose 0. Then the next term would be 10 choose 1. The next term would be 10 choose 2. And you would fill out the 10th row all the way until you got to 10 choose 10, right? All of these was 1 choose 1, 2 choose 2, 3 choose 3, 4 choose 4, all the way out to 10 choose 10. Well, we want to find the third term of the 10th row, so this is the 10th row, and this would be the third term. So all we have to do is find 10, choose 2. Well, if you have 10 objects and you're going to choose 2 of them at the time, using the formula from the previous page, it's n factorial over r factorial over n minus r factorial, which is 8 factorial. So this is 10 times 9 times 8 times dot 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 all the way to 1. 2 factorial is 2 times 1. 8 factorial is 8 all the way down to 1. Notice all of those cancel. 2 goes into 10 5 times, so I have 5 times 9, which is 45. So that tells me the third term in the 10th row is 45. Now only having to find 10, choose 2 was a lot more easy and simple than expanding out Pascal's triangle, and this huge triangle all the way out to the 10th row. So these are called the binomial coefficients. It's equivalent to Pascal's triangle, but often the binomial coefficients is more simple when you need to get to further down rows. Okay, so here we are going to expand this. Now, you do know how to expand it. To the 5th power, this means do a plus b times a plus b times a plus b times a plus b times a plus b. And you could multiply this out. You would just do a box method for these two and then get a trinomial, multiply it by that binomial, get a big thing here, then multiply it by that, get a big thing there, multiply it by that. But that would take a very long time. Instead, there is a pattern using the binomial coefficients or Pascal's triangle in order to expand this out. So this is 5, which means we're going to use the 5th row of Pascal's triangle. Use the 5th row. Okay, so when we expand it out, we are going to use the 5th row of Pascal's triangle, which we found in the previous example, which was 1, 5, 10, 10, 5, 1. That would be the 5th row. So the first number would be 1, and then be a to the biggest power, which would be a to the 5th. Because if we were to multiply all those a's together, we get a to the 5th, times it by b to the 0. Okay. Now I'll just show you the pattern, then we'll come back to it. The next binomial coefficient for the number in Pascal's triangle would be 5, and then a would to the next biggest number, 4th, so 5 and then 4. Then we're going to increase our b's by 1, b to the 1, plus the next binomial coefficient, 10, a to the 5, 4, 3, b to the 0, 1, 2. Plus the next 10, a squared, b cubed, plus the next one would be 5. So we start with a 5, 4, 3, 2, 1. And then b's we're going up, so we're at b to the 4th, plus the last binomial coefficient, 1, a to the 0, b to the 5th, which is a to the 5th when we simplified it, plus 5a to the 4th b, plus 10a cubed b squared, plus 10a squared b cubed, plus 5ab to the 4th, plus b to the 5th. Let's look at the sum of the exponents. Sum of the exponents is 5. Sum of those exponents is 5. Sum of the 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 exponents is always 5. We're on the 5th row. The coefficients are 1, 5, 10, 10, 5, 1. Okay, so that is a pattern that's always going to work. So let's use this to do the next one. So here, this 2b cubed would be like what we had b in the last term. So we're going to have to do all of that. And we're going to look at the 4th row. Okay, so I start off by writing 1, 4, 6, 4, 1. So I write out my binomial coefficients, that row of Pascal's triangle. And I take this first term, whatever it is, raise it to the 4th power, and that to the 0 power, which I don't need to write. And then I have a to the 3rd power times the whole thing, 2b cubed to what power is it going to be? To the 1, because it was to the 0 and then to the 1. Notice the sum of the exponents right now, 3 and 1, sum to be 4. Okay, we're going to add 6a, we decrease our a's by 1, so we're at a squared, times it by 2b cubed squared, because it was b to the 0, b to the 1, b squared, and squared goes into the 4th power. Add it to the next term, 4a to the 1, 2b cubed to the, or increasing, b to the 0, b to the 1, b squared, b cubed, plus 1. It's going to be a to the 0, which is 1, 2b cubed to the 4th. So now we just simplify. A to the 4th. So we have 2 times 4, which is 8. A cubed, b cubed. Plus, we have a 6, and then the 2 squared, which is 4, which gives me 24. A squared, and b cubed times b squared, we're using the rule a cubed squared, you multiply a to the 6th. So this is the letter b to the 6th. Plus we have a 4 times 2 to the 8th, or sorry, 2 to the 3rd, which is 8 times 4, which is 32. We have a to the 1 power, b to the 9th, plus 2 to the 4th, which is 16, and b to the 3 times 4, which is 12. Notice at this point, the exponents no longer sum to be 4. It was originally those exponents summed to be 4. Okay, that was the second example. Let's go on to this one. So when you have a negative, so our a term is going to be that, and our b term is going to be including the negative, which is going to cause the signs to alternate. So we're going to need the third row. Okay, so we're going to write out 1, 3, 3, 1. We're going to add all these things up. Okay, so it's 1 times 2x to the biggest power, and then this to the 0 power, which is nothing. 3 times the first term, 2x, decrease the exponent by 1. And then we have minus y squared to the 1 power. And then we have the first term, which is 2x to the 1 power, and then minus y squared. And we're increasing the y's, so that becomes y squared, plus 1 times 2x to the 0, which we don't need to write, minus y squared to the 3rd power, because the y's were 1, 2, 3. So this simplifies as 8x cubed. Then we have a minus 6. No, not 6. Minus 2 squared, which is 4, times 3 is 12. So minus 12x squared y squared. This minus squared becomes a positive. 2 times 3 is 6. We have an x. And we have a y squared squared, which is y to the 4th. And then we have a negative cubed, which is a negative. And then we have y squared cubed, which is y to the 6th. And we've expanded out. Of course, you can just multiply that out by itself 3 times using the box method, and then you get the same answer. Okay, so here we want to find the coefficient of the x squared in that thing. So you do not need to expand it out to the 10th term. I do not want to write out the 10th row of Pascal's triangle, but I am going to use my binomial coefficients. So I'm going to look at the 10th row, which is going to look like 10, choose 0, 10, choose 1, 10, choose 2, 10, choose 3, and so on, all the way out to 10, choose 10. And I want to find the x squared term. So with this first term, it's going to be this number times 2 to the 10th, this number times 2 to the 9th, 2 to the 8th, 2 to the 7th, all the way down to 2 to the 0. All right, we're going to multiply those. And then we're going to multiply negative 3x to the 0, negative 3x to the 1, negative 3x squared. Right, so you increase your x's. So this is my x squared term. So it's 10, choose 2, times 2 to the 8th, times negative 3x squared. Multiply all of this out. 10, choose 2 is 45. You can expand it out just like we have. 2 to the 8th is 256. Negative 3 is 9x squared. The coefficient is those numbers. We multiply it out, 103680, and that is your answer. Okay, so that was a lot of information. So what we did, wrote out the 10th row, and then just kind of expanded it out. We didn't do it formally, we just did it so we knew what it was. We normally multiply it out, and we found the coefficient, which is the numbers, 103,680. Have a great night.